Our first presenter is Jeff Garzik, a futurist, entrepreneur, and software engineer. Jeff is also the co-founder and CEO of Block. Jeff serves on the board of Coin Center and the advisory board of Bitfury, BitPay, Chain.com, Netkey, and Waypaver Labs. Jeff has delivered presentations on Bitcoin and blockchain at TEDx, State of Digital Money, many Bitcoin conferences, as well as private briefings to corporations, governments, central banks, and hedge funds. Jeff has a long history of early technology adoption. After helping to inaugurate CNN.com on the internet in the early 1990s, he worked for a succession of internet startups and service providers. At the same time, he worked continuously on open source software engineering projects over 2 decades. Involvement in one of the best known open source projects, the Linux kernel, led to an extended tenure at Linux leader Red Hat during the open source's most formative years. Jeff's work is found in every Android phone and data center Linux installation today. In July 2010, Jeff stumbled across a post describing Bitcoin. Immediately recognizing the potential of a concept previously thought impossible, decentralized digital money, he did what came naturally, developed Bitcoin open source software. That gave rise to the start of micro-businesses with Bitcoin at their foundation. Almost by accident, Jeff found himself at the heart of the global revolutionary technology phenomenon known as Bitcoin. Please welcome Jeff Garzik.
Thank you so much for this opportunity to speak. I wanted to present to this conference a short status report of, if you will, of where the community currently is, how scaling is coming along, etc. It's definitely a very positive path, I think, for Bitcoin overall, no matter how the debate sorts out. It's very naturally, as I like to say in open source, you air the dirty laundry in public, and the Bitcoin community certainly does that in these sorts of debates. So maybe we can cut through a little bit of the noise and focus on some metrics, some very specific benefits, costs, etc. So let me present a Bitcoin scaling status report. This is sponsored by Block. We started late last year with the idea of building a solid open source stack, not just the node or router, but associated middleware, analytics, etc., and delivering those safely and securely. So contact block.com if you are interested and would like more information. We're absolutely in the next phase of technology evolution, just like the PC, internet, and mobile eras. We have now the decentralized era as well, and that is typified by the Bitcoin protocol, which I draw an analogy to the TCP/IP protocol, the protocol that everyone will speak a common lingua franca of the value internet. There are several factors that make blockchain very useful, very specifically the Bitcoin blockchain. I'll not go into too much detail on this slide, but it suffice to say there are many parallels with the internet itself. It's very decentralized, it's permissionless, and it's really a neutral ground for many people to get involved with. One of the things that I'd like to highlight is what is a point of view for analysis? What is an approach to cut through the blockchain brouhaha, the block size brouhaha, get back to the scientific method, analysis, data points, and understand what we can learn from that. So the point of view that I'd like to present during this presentation is one of, number one, user-centric. Don't look necessarily at what is delivered at the network level, which can be a notably expansive feature set, very flexible, but what is delivered to the end user wallets, the end users who are actually experiencing Bitcoin on a day-to-day basis, sending value, storing value, using systems built on top of Bitcoin. What is their experience after you cut through all the layers of software, network upgrades, etc.? And what is the analysis method? Very simply, it's the scientific method. The specific analysis method is, I like to lean towards, is the Kepner-Trago, where you list essentially data points, you list advantages and disadvantages, and decouple the analysis of the problem to the proposed solution. And so we use that to analyze soft forks, hard forks, new features, existing features, etc. And point of view, field experience. Sometimes in software development, particularly in cryptography, it is very easy to wander off deep into the path of theory. What might happen if this might happen, if this might happen. And what anchors us to reality, what anchors us is field data from actual users. So that in this analysis is given more weight than potentially theoretical users that may experience a theoretical feature, etc., 3 or 4 chess moves and software evolutions down the line. So that's the basic approach, is analyze benefits and risks, list those out, and let users make their own analysis and conclusions from there. To provide some necessary background for some of the talks and analysis here, let's think a little bit about blocks, Bitcoin blocks that contain transactions, and the block space economics. Let me apologize and jump back one slide to say that the audience for this presentation is someone who is hopefully skilled in finance and knowledgeable in finance and economics, but not necessarily technical. So this is aimed at a non-technical audience, your quote-unquote average Bitcoin user, if there is such a thing. So getting back to block space economics and necessary background for the Bitcoin block size debate, etc., is blocks, we'll call that the base block or base block size, is in economic terms a fixed supply resource. It is delivered on average 1 megabyte every 10 minutes. And changing this capacity is changing the supply of a resource. So this is a limited resource for which users bid for space inside of each block with transaction fees, and therefore larger blocks, with other variables being equal, larger blocks would tend to drive transaction fees a bit lower. Similarly, smaller blocks, given current traffic volumes, would tend to increase the bidding, increase the transaction fees. Obviously, modulo price elasticity and several other variables, just simplifying for the cause of explanation. And if you have a large change in the supply of this resource block space, that's what is known as a supply shock in economic terms. And so you have a very large change in fee price, etc., over a small amount of time. So that's a supply shock. And then a rhetorical question, which I hope we'll address during this presentation, as well as for further research, of has control of a supply of an economic resource ever led to problems in history? I think the answer is fairly obvious to any student of history. So thinking about how block space economics works from a user market perspective is that users speculatively bid based on the current estimated fees and how quickly they want a transaction to be confirmed, to be stored in the Bitcoin blockchain. And this fee signaling is inherently complex for both users and miners, for both the consumers who are paying the fees and the producers who are receiving the fees and producing a service. For the users, they may want a rapid confirmation of transaction. They may want be less sensitive to transaction confirmation speed and bid less. But due to the probabilistic nature of block production, a user cannot know whether their transaction will be take 1 hour to achieve one confirmation, which is unlikely but possible. It happens on a daily basis. And so for the user, they are paying for a likely production of service from the Bitcoin network, but they may not be delivered that service even if miners include their transaction in the very next block that's confirmed next by the network. So the fee signaling for users is very complex. It's difficult to reason. And if we were going to give the average user a sort of knob or decision to tweak or turn, it's really a security and transaction confirmation speed slider that gives them a limited set of above average, average, or below average choices, but still no specific deadline for confirmation due to the block confirmation process. Now further, miners are also similarly not very well signaled by transaction fees. The current block reward, the 12.5 per block increase in the currency supply, very much swamps transaction fees right now in terms of signaling to miners in terms of behavior. And furthermore, it's very difficult to understand any or divine any sort of behavior and react to it in terms of transaction fees other than the very simplistic more fees is better, I get paid slightly more. But in terms of how does that motivate miners to change their software? How does that motivate miners to update their block generation algorithms, et cetera? Is that in truth, through the layers of fee signaling to miners using a different version of Bitcoin D, et cetera, is a very complex chain that involves development as well. And so fee signaling on both sides of the equation is very opaque, and that is further compounded by dumb software. Now, this has improved on the wallet side in recent months as transaction fees have increased. But traditionally, it is somewhat difficult for wallet software today to come up with a good optimal algorithm for deciding which unspent transaction outputs should be included in a transaction. Naively, on all other monetary networks payment systems, a transaction fee is either a fixed price per transaction or it's a percentage of the value. Whereas Bitcoin is quite different. The transaction fee is a function of transaction size. And so you might have a very small value transaction, which requires a lot of UTXOs. Therefore, it requires a very high transaction fee. And conversely, you might have a very high value transaction, which only consumes a single UTXO. Therefore, it's a small transaction. Therefore, it requires a small transaction fee. So again, the point of all this explanation is that fee signaling, fee reasoning is very difficult, even for normal users, and much less for wallet developers. And they have to they have in the past relied on overly simplified algorithms for paying fees that wound up, as transaction fees increase, to be decidedly non-optimal and results in a poor wallet software user experience. High confirmation times, transactions not confirming at all, etc., through no fault of the user. And so you have opaque fee signaling and compounded by software that needs improvement. Now, some more background and perhaps inject a little interest into the block size debate, as it were, is this was highlighted in BIP 100 background document. There is a notable tension between certain economic actors. I'm not divining any intent or not ascribing any intent to anyone in the Bitcoin community. I feel this is an important data point and observation, a neutral observation, that some economic actors are fee sensitive and some are not. And this trickles out into several interesting scenarios that play out into block size today. So I would argue that the block size debate is not really about, or the capacity debate, scaling Bitcoin, etc., however you want to characterize it, it's not about centralization versus decentralization, as most of the mainstream proposals, even on the hard fork side, do not result in notable changes in levels of decentralization versus a soft fork that also increases capacity to 4 megabytes. Similarly, there are some people who want very, very huge blocks, but again, that doesn't seem to be the wider consensus, in that more people seem to be interested in what makes sense for the Bitcoin network, which is heartening. But so my hypothesis, and I feel this was illustrated by the Bitcoin XT letter and split, most notably, is that there is a tension between not, as some people have suggested, a tension between venture-backed companies and normal growth, etc., but it's very much more fundamental. It's very much more an economic incentive issue and the fallout from that. So Bitcoin is an asset class. For example, just simply holding Bitcoin and using that as a non-correlated asset class, while the U.S. dollar value changes, gold changes, stocks, bonds, etc. It's Bitcoin is very much proving to be not correlated with those assets, and simply holding it, using it as an asset either through an ETF, which is coming very soon, or some of the existing ETNs, or simply holding, is that's not fee sensitive at all. The comparison in terms of fees is you can consider the physical storage fee of gold, or negative interest rates on deposits, etc. You compare that to Bitcoin transaction fees, and they are very, very small in comparison. And even if transaction fees go up 1,000%, the Bitcoin as asset class holders are not that sensitive to that. However, there are other economic actors in the same pond, as it were, which are fee sensitive, and the current trajectory has likely had a negative impact. And that's number one, Bitcoin as payments, which is absolutely fee sensitive, and number two, emerging blockchain applications. These are the counterparties, the on-chain document time stamping, some of the other non-currency applications that people are deploying. So those two are fee sensitive, and therefore they were, as I believe was illustrated by the signers of that controversial Bitcoin XT letter, was they are much more sensitive to this current trajectory. Notably, Bitcoin's as payments is very sensitive to current practice, which is zero confirmation transactions and a risk-based approach. to security gauging and waiting for those confirmations a little bit later versus a much more longer term but much more secure payment strategy, which is Lightning Network and some of the current developments that people are building. And so the payment experience has really declined quite notably because current practice is disadvantaged by higher fees and less predictable confirmation times, et cetera. And the transition technology is not available yet. So the user experience is sort of caught in that gap between what we've always done and version 2. And it looks like that scenario will likely continue for several months, at least into the future. Recent metrics. So this is a Bitcoin status report. Some of the metrics price is up notably, as is the dollar adjusted transaction fee. And as a note, I include the average transaction fee in dollars because that's intended to simulate, again, the average user experience. You're transferring, as Bitcoin exchange rate goes up, more value as the transaction fee in BTC increases. We've seen increase in transactions per day. The network strength continues to increase, which is even more notable and laudable because we went through the halving, and that is post-halving numbers. On the perhaps less positive side, the number of nodes continues to decline, the full nodes on the network. Median blocks, we've transitioned from a year ago, mostly not full, to usually full. And in terms of hash power, the number of miners, then this is relevant in soft forks, needed to achieve a 95% lock-in of new consensus rules. That's 8 mining pools currently. So some recent Bitcoin network improvements, again, focusing on what's either user visible or likely to be user visible. There are quite a number of many fixes, changes. The list is too long to list. Very positive, keeping things running, moving things forward. These are user visible or going to be user visible. Mempool limiting is a feature that at each node increases the limit that will be of a transaction fee that will be accepted by the relaying node. And this is used such that if there are large bursts of transactions, this will cap and keep nodes stable across the entire network, and temporarily increase the fee until the burst is over. So makes the network more healthy, more self-adjusting. The signature validation with the lib SECP 256K1 is increases one of the two key, or improves one of the two key metrics of any blockchain network. Those two metrics are cost of attack and cost of validation, and this one change significantly reduces the cost of validation of each block. Similarly, two new features about to be rolled out: compact block relay and child pays for parent. Very positive features, and two foundational elements which will start showing up in applications in the months ahead are check lock time verify, check sequence verify. Those make Lightning Network and other contract and contract chains and payment channels much more secure. So let's contemplate on-chain scaling, network upgrades, etc. And what do we mean by that is changing the consensus rules that everyone on the network must follow. And so therefore, you're really talking about the process of meta-consensus. How do we change these consensus rules? And so I liken it a bit to the U.S. Constitution in that there's a much higher bar to change these rules. Both hard forks and soft forks are types of network upgrades which can, number one, remove existing rules that users may be following today, and potentially break existing software or filter out previously working transactions. Or number two, add new rules that users must follow into the future. So that's essentially what soft forks and hard forks network upgrades can do. And in the vein of presenting, again, data points on both benefits and risks, I feel this is something that's been missing from the scaling debate. Quite notably, you'll see lists of benefits with no lists of risks, etc. So for hard forks, the benefits column, there's a high amount of user consent. It's not just miners, but the network has to agree to this. There's a very clear upgrade path to a new set of rules. And you have reduced software complexity. Deep under the hood, it is much less complex to affect, for example, a capacity change to base block size that does not require changes to transaction signing, that does not require major changes to wallets, etc. And there's a clear user choice and a market path for a fork A or B. What are the risks? Number one, it requires a long lead time. It requires planning, testing, and most notably a communications component, messaging to the users in the market that this network upgrade is contemplated. On the risks column, again, it's disruptive. Most notably, we saw this with Ethereum ETH Classic, which, in my opinion, was a rushed fork. And it's essentially an ongoing network partition in a worst case that leaves users confused. So those are some of the notable benefits, notable risks in a hard fork. Similarly, soft forks are not risk-free as well. On the benefits side is this in bold because it's such the large benefit. The reason why the community is choosing soft forks for current tech upgrades is, number one, it's a backward compatible upgrade. Quite simply, the network keeps working. And changes require minimal approval, which means more features faster. And it's asymmetric in terms of it's difficult to avoid a soft fork, which makes it far more likely that the soft fork will succeed or roll out. Now, the risks are undercovered and very much should be noted as well. It is very much a rule by, and if you recall the metric from a couple slides ago, a tiny few who choose to agree to filter a network in a new way. And therefore, repeated soft forks are repeated agreements, or, a positive collusion, if you will, of these tiny few to change the rules that the entire network is locked into. Soft forks, very specifically, from a, again, average user point of view, cannot be considered opt-in because the entire network is locked in to the new consensus rules, regardless or not. And asymmetric nature of soft forks makes that a risk as well, in that if it's a controversial soft fork, it's more difficult to reverse or challenge. Each soft fork, if the node does not upgrade, faces a security reduction. Now remember, one of the reasons, one of the incentives for running a Bitcoin node is that you receive a trustless version of the distributed ledger, the Bitcoin ledger, rather than trusting another party. With each soft fork, you trust another party, the mining pool network, to validate this one rule on your behalf. And therefore, the incentive in a soft fork on each node that doesn't upgrade, the incentive to run that node is reduced, and the local security, that local trustlessness, is reduced, and the trust and reliance on miners is increased. Another notable risk was illustrated by prior to the Ethereum soft fork was the hard fork was the Ethereum soft fork proposal, where they proposed to simply filter out one or more of the DAO-related transactions. So that obviously is, thankfully they pulled back from that. That would have been a very notable minor moral hazard, which is a very specific economic term, on the part of Ethereum miners. So those are some of the risks of any soft fork as well. Now, I'm a little bit over time, so I'm going to rush through this a bit, but the SegWit deserves a mention, a bit of a review, in that it has benefits and risks as well. You can go to bitcoincore.org, and again, this is a communications issue in that the document lists benefits but no risks or caveats or costs. So a full and neutral review should list both benefits and risks. The messaging for SegWit has been a capacity increase, but in general, the notable features that it delivers, it's very much a foundational change that enables other changes. It solves transaction malleability quite completely and very elegantly. It begins to address UTXO cost, which is an economic issue in the Bitcoin system of this database with one-time storage costs for lifetime storage. So this begins to address that, and it introduces a upgradable script vector that serves as a Lightning Network enabler. However, risk side, there is, again, soft forks are not opt-in or risk-free. This is the first economic soft fork. It introduces new precedents whereby devs and miners are directly picking the new size of a economic resource block space of which there is limited supply. So going back to that economic background slide, this is a voluntary upgrade to SegWit, which implies a very long transition with capacity that, again, from the end user wallet perspective, as it applies to relief from block pressure, hopefully impacting reducing transaction fees. Capacity is unlikely to be user impactful before January 2017 at the earliest, because SegWit is really a two-step upgrade. Number one, it's enabled on the network, but that does not give any users new capacity. It gives users the ability to enable capacity, which is quite different. And there is very little user benefit, and this is not a criticism, this is very much an observation of SegWit, a communications challenge, a challenge selling the features to the community, is that there's very little user visible impact and benefit versus the complexity of the change. Now, again, on the risk side, there's notable transitional complexity. Wallets, exchanges, other up-layer software above the node needs to understand the old transaction ID, the new, less malleable transaction ID. Potentially, does your recipient accept SegWit or not? There's some BIP70 analysis, negotiation, etc. And in general, even trickling down to the low-level network protocol, there's some confusion due to there are now two types of transaction IDs on the network, and you have to know which one is which, and that increases the complexity of the software. So ultimately, you don't have a clean upgrade from A to B. You upgrade from A to a situation where you have A and B coexisting for months and years into the future. So that's where some of the complexity comes from. And that's going to take time for exchanges to upgrade. Therefore, it's going to take time for that capacity to come online due to that upgrade. Again, And then economic complexity. This creates what I describe as an analogy of two buckets, where the base block, the limited to 1 megabyte block, is one bucket that you fill with transactions. And metaphorically, we have adding a second bucket. And the economic complexity to the wallet software, if we jump back to my previous description of how complex fees are today without SegWit, and how difficult signaling is, and how complex it is to calculate fees as a wallet, you now have two buckets with two separate pricing schedules, as it were, to simplify a bit. And you have new economic choices, where some economic actors are only using the base block and only bidding for the base block, whereas newer SegWit-aware economic actors are bidding for both buckets. And that increases the economic complexity of that bidding process quite a bit. So the fee signaling gets, I would describe it as exponentially more complex in terms of trying to reason out where do you store your transaction? Does it make sense in only the base block versus the new SegWit, et cetera. And on the miner side, it's even more opaque which sort of signaling you'll receive. So there are several elements of complexity that are not apparent at the network level, which are apparent at the economic and wallet level, which are only beginning to be explored, and the transition is going to take quite a while. To round it out and to summarize, this is Bitcoin's first economic soft fork. It's not just adding technical features. We're increasing the limited supply resource, the base block size, with some extended block space. That's one constant, that specific number, economic number that's being added to the system. Number two, the UTXO discount. You get a pricing discount, as it were, for storing in the new block space. And again, with the analogy of two buckets of a different size, each of them are filled with water at different rates and prices, and now you have to discern at the wallet software level which bucket and which price. So that is, number one, introducing new economic changes, which is a precedent in and of itself. And then number two, that is a complexity that is a bit underanalyzed, and it's going to take several months to roll out. Another element of SegWit specifically, because this is very important, it's been messaged as a capacity increase, is to compare the predictability of this versus other hard fork solutions. In Bitcoin, as you see, the block period is predictable. That's on average targeted every 10 minutes. The block reward, again, the supply, very predictable, programmed into the software. It's every 4 years halving. The block space today, it's very predictable. It's fixed at 1 megabyte of supply. With the BIP 109 proposed, that is also predictable in terms of, number one, when the block space capacity is delivered, and number two, how much capacity is delivered. So in contrast, SegWit, which takes a new approach of delivering some capacity increases through the use of some more novel encryption, say, crypto, it's unpredictable on the byte count side, and it's unpredictable on the capacity and delivery calendar date side. So two elements of predictability there. So in conclusion, block space should be replaced. The humans in the decision-making process should be replaced by algorithms as soon as possible. Both BIP 109, several of the other hard fork proposals, and SegWit fail this criteria. This is where FlexCap and some of the other discussions start. A tiny few choosing Bitcoin's economics is anti to Bitcoin's ethos. Soft forks are neither opt-in nor risk-free. They introduce, soft forks introduce layers of complexity because multiple systems, the old and new, must coexist and be managed simultaneously as users transition from old to new over time. On the communication side, it's important to give both sides of the analysis to users, not just the benefits. Outline the risks as well of any change. Time has real costs. Consider the impact of failing to increase capacity at a certain pace on existing users and businesses who will simply be priced out of the market. Whereas getting back to, again, the economic actor tension, this is not ascribing any malicious intent, simply following economic incentives. Some people are not sensitive to that time and transaction fee pressure, and some uses are. And that has had a notable impact on some ecosystem players, such as like Shapeshift and Blockchain, who have seen much higher support tickets, confirmation times, etc., and not had an impact on those that are less sensitive to transaction fees. And finally, I do agree that SegWit is a useful yet complex foundational change, and to avoid issues related to economics of a tiny few picking new economics in Bitcoin, that it should be rolled out in a hard fork where users actually have the opportunity to agree, disagree, etc. So thank you for your time, and I'm unfortunately over time a bit, but I hope that there's still some time for Q&A. Our wonderful moderators will take it from here, I think.
So Jeff, we do have time for questions and answers. We do have a few minutes anyway, so if there's any questions and people would like to enter their questions into the Q&A box, please do so now, and we'll see where we go.
Perfect.
We'll give it a minute. I think you were pretty complete in your presentation, so that may be indicative of the issues.
I tried to touch on a lot of the topics that people were asking about and give some intellectual food for thought. If I were to take it to a high level, I tried to avoid a lot of the ascribing of intent that people do during this debate. I think that if you assume good faith, there are usually reasons such as economic that for people do what they do, and there are different motivations, different incentives that pull people in different directions. So it's incumbent on us to really look at why people are saying what they say. Do you foresee the SegWit discount being changed? That is an excellent question. It is one of the aspects of SegWit, the SegWit discount, that is quite under-analyzed, and it is, as far as I can tell, just sort of a finger-in-the-wind number, of which we already have several in Bitcoin, and now we have another that we may need to change in the future. And I think that, but it's too early to say, based on lack of field experience, whether we can make that automated or not. So next question. Mention the difference between bidding for base supply and extended SegWit supply. Can you give an example of how you tailor transactions? Well, it's basically more a question of if it's more economically advantageous to use the base block, then you will simply not use SegWit. You'll do, I guess, a version 1 or a legacy transaction, versus if it's economically advantageous and the other party can accept SegWit, and you know that, then it's more likely to be using that extended supply. So tailoring the transactions are going to be sort of binary SegWit or not decision. So excellent. We're getting a bunch of good questions now. So a hard fork is and the next question, and that's really an excellent user experience question of if we do a hard fork and I don't update, what happens? It's really a question of the specific method of soft fork rollout. The current hard fork thinking is that you want to avoid any sort of fund loss or minimize the negative experience for being on the other side of the fork. And so obviously if you're sort of an ETH Classic type shape, you can do something different. But the current thinking for hard forks, if they roll out sort of in a Bitcoin Core friendly way, is you do a soft fork hard fork that locks in the hash power and ensures that the losing fork, as it were, doesn't see any transaction activity. And so that's sort of a added safety measure. Let's see, next question. What are your thoughts on the idea that Bitcoin needs multiple layers to scale versus doing all scaling on layer one? Many protocols use a multi-layer approach, etc. This is another good question. The answer is really both. We have to scale layer one, even if Lightning is going to be a moderate success. We have to scale layer one right now because it serves as a disincentive for building new applications on top of Bitcoin, etc. So there are quite a few reasons that you need to scale layer one. But here's where the message gets very, very complicated, and it's not an either or, is that you can't put all the world's coffees on the layer one blockchain. And so inevitably, you're going to have a multi-layer approach. And as such, you're, again, going to need to scale the layer one. You're going to need to scale the base block size to support all these layer two developments. Next question, who would you see preparing and offering a hard fork block size increase? I think that there are several interested parties who are just sitting on the sidelines for the moment, waiting to see how the block size debate falls out, as it were, letting the dust settle a little bit. And if there's no planning, if there's no movement towards a block size resolution, then I think that a number of people are going to start, developing their own fork code. I know that there's a small splinter effort, mainly on Reddit, etc., that people are sort of charged up about. But I don't think that the main Bitcoin network is going to follow those sort of splinter efforts. It's really going to be something that's signaled by a lot of the exchanges, and less so, I think, than the miners, as the media has. The exchanges are really some of the focal points, those bridges and gateways on and off Bitcoin, that they tend to signal more than miners whether a hard fork's acceptable, what's acceptable for the network, as that's a bit of a proxy for users and price. Next question, how would you respond to those to say that a SegWit hard fork would force some people off the network? Is agreed, and I just covered that on that previous question, is that that's a risk by a hard fork that you have to balance against the economic risks of ensconcing a tiny few number of people making economic decisions about Bitcoin. And so I argue, and this is personal opinion and not a data point certainly, that we don't need people, just a bare few minimum people choosing, okay, this UTXO will have a 75% discount and the entire network has to follow. And that's essentially what a soft fork offers, is that the entire network has to follow the decisions made by a tiny few. And if you start to create the practice, the precedent for rolling out economic changes where the only approval for those changes are these tiny few people, then essentially you're recreating something that Bitcoin is absolutely antithetical to. That's, the Federal Reserve FOMC, or some other, economic steering committee for Bitcoin, which is something that we don't want. And that's what soft forks encourage. And so existentially, and this is answering your question, is it better to have a fork that on the losing side doesn't have any transactions, that's the hard fork soft fork, and is a cleaner upgrade that is consented to by a larger part of the network, or a upgrade that does not eject people from the network, but it does unconditionally, without the network consent, change key pieces of Bitcoin's economics, such as the block space economics, which in turn changes the fee market. So that's sort of boiling down those questions to hard fork or soft fork. Is soft fork on a technical basis rolling out just a pay to script hash, check lock time, verify, etc. That is not changing. That's not an economic soft fork. But changing one of these constants is a new precedent for Bitcoin, and that's really the hard fork or soft fork type of question. So several questions have gone by. Let's see. I think that the fork, would you be willing to support a fork of the Bitcoin network with or without majority support? The network effect is ultimately what makes, I think, Bitcoin useful. And so I'll give you the business answer, which is business block will follow the economic consensus. And so if that economic consensus with wallets, exchanges, far more than just miners, is with the majority, whatever they do, then we'll make do. So I don't think that a splinter effort that is a tiny majority is worth putting much time and effort towards. But that's my business answer. That is really aligned towards what's going to align itself with the most customers. And I think we're getting pretty close to the end of the time segment here. Let's get this one last question here. What do you think of the strategy of everyone set your own limit strategy of Bitcoin Unlimited, where you, quote, reject blocks of a certain size unless the most worked chain is longer? That is... It's a conflict, I think, between technology and economics, in that we're getting into economic theory, in that it has been demonstrated that a fee equilibrium exists in absence of a hard block size limit. And so the economic theory that Bitcoin Unlimited is aligning itself with has successfully been demonstrated in the past with Bitcoin. However, the limit also serves the function of DOS prevention. And so from that standpoint, it's very difficult if you have everyone set your own limit and accomplish a collective action of preventing that DOS, or DDoS rather. And so I think there's a natural tension there between the economics they want to accomplish and the actual implementation that they have in the field.
We have time for one more question, Jeff.
Okay, great. So one more question, and are you concerned that Lightning Network security model breaks down if the underlying main chain is running at full capacity? Actually, no, that quite honestly doesn't concern me at all. That will work itself out quite quickly in terms of pricing. So people will very quickly figure out what is best practice and not worry about that. I do have concerns on the Lightning side in terms of, number one, again, pace. This is a very complex technology, and the economics and the economic incentives of the Lightning Network are not proven, and it's not fully proven, most notably, that it won't result in a very highly centralized hub network that then most people using Bitcoin for payments due to fees are incented to use. And so I think the very specific issue you highlight is I don't believe an issue that'll quickly settle out. But the larger question of, is this the be-all, end-all answer for Bitcoin payments? Will this be the replacement for zero confirmation transactions that the proponents hope it will? That, from the average end user perspective, that's very much an open question. It might be a reinvention of a centralized payment network that is much, much more centralized than the Bitcoin layer one network today. And so there's a sorting out of economics and economic incentives as to who will run hubs, how much will that cost, et cetera. And that is the bigger open question for Lightning. I think that if the chain's running at full capacity, that just makes the Lightning fees more expensive. You have a feedback mechanism there. And so Lightning will, if you fail to scale on-chain, then Lightning will become just another expensive payment mechanism. So even for Lightning another layer 2, you need that layer 1 on-chain scaling to get us over the gap until the technology is ready and proven, and to enable those layer 2 technologies to scale.
Excellent. Thank you so much, Jeff. It's very much appreciated that you've been able to speak with us today. We're going to take a 5-minute break and be back shortly with Emin Glensier. So thank you very much.
Thank you for your time, and thanks for listening.